Good morning. This is Math 11. We're going to consider topics in Math 11, functions. And we're also going to consider divine proportion. In Filipino, we call it maladiyosang proportion. And also, we're going to solve systems. We're also going to consider some aspects on a line segment, like for a line segment, which is the distance between 2 points. So these are the topics that we are going to consider in Mathematics 11. We're going to start with our first example, of a function y equals 3x squared plus 7x minus 49. When we graph that, now in general, the quadratic function has this form. Y equals ax squared plus bx plus c, where a is the coefficient of x squared, and b is the coefficient of x, and c is the constant term, meaning there is no x. In our example here, this one is your a, 3. B is plus 7, and C is negative 49. This is the general formula for a quadratic function. Now, for this type of quadratic function, what do we know about it? First of all, its graph is a parabola. As you can see the label, it's 3x squared minus 7x plus 49. Minus 49. Its graph is a parabola. Now, what do we know also, or what should we know about the parabola? First of all, we are very interested in its vertex. The vertex, for any parabola in general of this type, ax squared plus bx plus c, it's one of the fixed figures in algebra, in mathematics. Like circle, you know it's always round. Now, for a parabola, it's something like this. It has a lowest point, and it goes up. Or it goes something like this. It has a highest point. It goes down. But sometimes, the parabola could also be lying down, but also of the same shape, either pointing to the right or pointing to the left. But for our purpose, that is not a function anymore. We are going to just consider the parabola that either goes up or either goes down. So, we are interested in the vertex. First of all, if a is greater than 0, then the vertex is minimum and the parabola goes up. A meaning the coefficient of x squared. Now, if the vertex is maximum, the parabola goes down and a is negative. But our example here is a is positive, so it goes up. More or less, we will know that even if we do not see the graph there yet as indicated, we know that it will look like this. Whatever the formula, whether a greater than 0 or a less than 0, this is the vertex. Minus b over 2a, that will be the abscissa of the vertex, and the ordinate of the vertex is 4ac minus b squared over 4. Okay, so this is correct. So this is you should remember this. Mathematics trains you to remember things, and one of the things you have to memorize or remember will be minus b over 2a and 4ac minus b squared over 4a. So, applying this to our parabola, first of all, let us see graphically what else do we have to know. So, if we look at the vertex, so we can see more or less what it should be equal to without applying the formula. Just by graph reading, we call it V vertex by the graph will be equal to more or less, what is that, Carlo? Negative. So, about negative 1 point something, about negative 1 more or less. So let us say approximately equal to negative 1. How about the ordinate? Negative 53. Okay. So this is just by graphing, no? So more or less, the importance of graphing before you actually solve is that you will know where the values are, more or less. Because if you just solve and then without an approximate value, so that could be a counter check. We'll solve later. Now, next important aspect about graphs of functions are intercepts. First, the x-intercept. The x-intercept is the abscissa of the intersection with the x-axis. Now, for that parabola, as Carlo is pointing out, the first x-intercept is approximately 3, and the second x-intercept is approximately what? Negative 5.5. Again, that is graphical, and we'll just solve later. What will be the exact values? Because that's just approximate, then we can give the exact values by actual solution. Now, what are the other intercepts? The y-intercept. The y-intercept, we call this the x-intercept. This is the y-intercept, is the ordinate. We call this x-intercept. And this is the y-intercept. That is the ordinate of the intersection with the y-axis, of the graph with the y-axis. So, Carlo, will you point out to the y-intercept? And approximately, the y-intercept is approximately negative what? Negative 50 or negative 49? Negative 49. Approximately. When you solve, actually, it should not really, you should not be getting negative 60 or positive 70. It should be very close to these values. Now, what else are we supposed to know? Now, we are also interested in what we call zeros of the function. When we say function and we say graph, the graph and the function are interchangeable. The graph could also be called the function, or the function could also be the graph. So, for instance, that sort of letter U to represent the graph of a parabola could also be called the function. So, this set of points here could be the function. Okay. Now, zeros of the function will be the values of x such that, symbol for such that, y is equal to 0. Or in other words, when the function is 0. So, will you point out, Carlo, to the zeros of the function? Zeros of the function when y is 0, meaning x-axis, no? So, as you can see, the x-intercept and the zeros of the function are numerically the same. They graphically mean the same thing. So, zeros of the function, values of x such that y is equal to 0 means this is the same as the x-intercept. So, if graphically, so we notice that what we are doing here is approximating the values by graphical method. Graphically, we want to get the zeros of the function. We already were able to get the abscissa or the x-intercept. These are also the zeros of the function. So the zeros are x is equal to 3 and approximately, this is the symbol for approximately, x is equal to 3 and x is equal to approximately minus 5.5. So the same thing here. So our next example of a function, we call this a linear function because the coefficients of each variable is 1. Whereas this one, the highest degree is 2, that's why it's quadratic. Carlo, could you now graph 2x plus 5y equal to 1? There. So, from the graph there, the red portion, what are the important things about we call this the linear function. We can also write the equation, so linear function 2x plus 5y equals 1. Or, we can also solve for y in terms of x. So, 5y equals 1 minus 2x, we transpose 2x. Or, solving for y, we divide both sides by 5. And so, we get 1 minus 2x divided by 5. Or, we can write this as minus 2/5 x plus 1/5. So, this one has been rewritten as y equal to minus 2/5 x plus 1/5. This analytic formula can also be represented as y equal to mx plus b, where m here is the formula, is the slope of the line. The slope of the line is the measure of its inclination with the x-axis. And this one, the b here, is the y-intercept. What are the things that we might like to know about the linear function? We are interested in its slope. So if we write the equation as y equals mx plus b, like what we did here, and you have y equals minus 2/5 x plus 1/5, therefore, what is the slope? M, which is the coefficient of x, is minus 2/5. That is the slope of the line for the linear function. Well, just like the parabola, we are also interested in looking for its x-intercept. Y-intercept. And its zeros. It has only one zero, no? So just we could say 0. 0 of the line of 2x plus 5y equals 1. Okay. X-intercept, please refer to the graph on the PowerPoint. X-intercept, will you point that out, Carlo? Is there intersection of the line with the x-axis? And approximately, again, we are just doing it by graphical method. That is approximately what? 0.5. Okay. Now, how about the y-intercept? Could you point that out, Carlo? There again, it is the intersection of the red line with the x-axis. Intersection of the line with the y-axis. And approximately, what is that equal to? 0.2 approximately.